Okay, so as I promised, here's my video with examples of exponential equations that require factoring or factorizing, and let's look at this first one. In this one, what we have, as you can see, we've got negative 3 times 5 to the power of x minus 1 plus plus. Well, you can see it's an exponential expression, and the first thing that we are going to do is to isolate the power that I want to solve. Do you recognize the power that I want to solve is 5 to the power of x? I hope so. Well, let's see. So we've got negative 3 times, and we know when we add exponents, it's the same as multiplying bases, same bases, with those exponents. So this can become negative 3 times 5 to the power x times 5 to the power of 1 minus 4 times 5 to the power of x times 5 to the power of 9 is equal to, and on this side we've got negative 1562503. Okay, so this is a very ugly expression, but again, just relax, keep calm, okay, and just do what you know to do. Okay, so here what we have is we've got two terms on this side, and again, just remember that when we have three terms, we need to factorize usually to solve this. Okay, so here we can see we've got three terms. Two of the terms contain an unknown, 5 to the power of x, and it's the same factor. So I'm going to take out that factor, 5 to the power of x. I'm going to take it out as a common factor. What's remaining? There's a negative 3 and a 5, which when I multiply gives me negative 15. And on this side, it's also negative 4 and a 5 to the power of 9. Oh, 5 to the power of 9. That's a massive number. Let's see, what is it? Okay. 5 to the power of 9, okay, 195, and times 4, negative 4 actually, okay, that gives me negative 7812500, 7812500 is equal to this negative 152.2503. This is ugly numbers. You'll seldom get something like that in a test, but let's continue with this. So what do we have? We now have negative 15, this thing, negative 7812, minus the 15 as well, so we get another negative 15 is equal to negative 700. Now that is the coefficient, or that's something that's multiplying this power. I want to get this power on its own. So since it's multiplying this side, I'm going to divide it on the other side. Okay, so on my calculator here, when I want to use a number that I want to divide with, I use this little 1 over x symbol. So I'm going to put 1 over x. That makes this a fraction. And then I'm going to multiply it. Why not divide it? Well, because by making it a fraction, I am doing the division operation. Now I'm going to multiply it with, and I'm just going to multiply it with the numerator, and you'll see why in a minute. Okay, so I'm just multiplying the numerator, 1562503, and that negative I'm going to assume belongs to the numerator. And what do we get? Okay, 0.2. Now 0.2 is 1 over 5. Okay, so this becomes 5 to the power of x times, and so the negatives cancelled, so it's 1 over 5 divided by 125. Now I don't want to write it like that. I'll rather write it as 1 over 5 times 125. Why do I do that? Well, you'll remember that 1 over 5 is actually 5 to the power of negative 1, and to have something to the power of negative 1 is the same as dividing, so I'll include it in the denominator where it is dividing, and this means it is 5 to the power of x is equal, in the bottom we get 5 to the power of 5 times 125 is 625. 625 is 5 to the power of 4, but because it's in the denominator, it's 5 to the power of negative 4. That means that x is equal to negative 4. Okay, that's not too difficult. Let's try this one. This one looks slightly simpler actually, but here what you are going to see is once I've isolated my power, I'm going to say this is 4 times 2 to the power of x times 2 to the power of 1 is equal to 65 minus 2 times 2 to the power of x times 2 to the power of negative 4. Okay, now you notice the problem is I can't take out a common factor. I've got 3 terms, so I can't just make base equal to base or power equal to power. The other problem is I can't now continue because I can't take out a common factor. My 2 terms that have the 2 common factors I want to take out are on either side. So now what I would do is simply add this term on this side to get rid of it, and add it on this side to add it. So 4 times 2 to the power of x times 2 plus 2 times 2 to the power of x times 2 to the power of negative 4 is equal to 65. Okay, and then on the right hand side, if I take out my common factor, 2 to the power of x, okay, I'm left with 4 times 2, that's 8, plus, and this time 2 times 2 to the power of negative 4 is 1 over 16, 1 over 2 to the power of 4. So I've got 8 plus 2 times this is 2 sixteenths. And 2 sixteenths is 1/8. Okay, makes sense? Okay, so I've got 1/8. Shouldn't have done this here, but anyway, so I've got 1/8. So it's 8 plus 1/8 is equal to 65. Now I'm going to do this one without a calculator because I can. Okay, and that is 2 to the power of x. 8 plus 1/8. I must take 8 over 8. I want something over 8 to get this 8 over 1 to be something over 8. I must multiply the denominator with an 8, so I must multiply the numerator with an 8. So it's 8 times 8 is 64 plus 1 is 65. Oh, can you see what's happening? 65 over 8 is equal to 65. Okay, that's great. So in other words, to get rid of this thing, I must multiply with the reciprocal. Okay, so I must multiply both sides with 8 over 65. So this side, 8 over 65. That gives me just 8. Okay, on this side, they multiply to give me 1. So on the other side, I'm just left with 8. And here you don't even need to make same bases. Hopefully you can do it by inspection by saying, well, 2 to the power of 3 is equal to 8. So that makes x equal to 3. Okay, here's once again an ugly one. Okay, I suspect this one should have an equal to 0 there. I must have just written it down wrong. I apologize. So there's an equal to 0 to make it an equation. Okay, and okay. This time, what I'm going to do is I'm not going to do all the calculations in between. I'm just going to say 2 times 5x times 5 to the power of positive 1, sorry, just says 5 to the power of 1 minus 5x, I shouldn't use that x, I should use that x, there we go, times 5 to the power of negative 6. Okay, and once again, in the end, what we want to do is actually take out a common factor here and divide what's left with the constant term. You'll see it's not a trinomial. If it was a trinomial, then we would want to keep this here. It's not a trinomial because my isolated power is not squared. See, if I make this a k, it's not k squared. So I'm going to take out 5 to the power of x as an exponent. What I'll be left with is 2 times 5, that's 10, minus 5 to the power of negative 6, minus 5 to the power of negative 6. Okay, and this would all be equal to, let's see, this thing, which is 156,249 over 312 over 3125. Okay, so I just added this on both sides, and the reason why, so that when I take this term, I just divide it on both sides. So in other words, this is 156,249 over 3125, and now I'm just going to divide both sides with this expression. 10 minus 5 to the power of negative 6 is equal to that. So I'm also going to divide this with 10 minus 5 to the power of negative 6. Okay, and when we divide, we only need to divide the numerator or multiply the denominator. So I'm just going to do that. I'm going to have 5 to the power of x is equal to, I'm just going to divide the numerator, and you'll see why, because it's going to give me a nice number. Because I've got 156,249 divided by this answer, and it's in brackets, 10 minus 5 to the power of 6, negative 6. And I get 15625. So I get 15625. Let's divide this 15625 with 31 divided by 3125 and 3125, and what do we get? We get just the answer 5. That's beautiful. So we see x is equal to 1.